Good morning, good afternoon, and good evening. A truly global webinar we have today, and I would like to welcome you to this web seminar of today on feedstocks for anaerobic digestion, organized by DiBiCoo. I'm Harmen Dekker. I'm director of the European Biogas Association, and I will try to guide you through this conference or this seminar of today. Just to have a little intro. The biogas sector is starting to be recognized really in the world. As you might know, there are some reports coming out, and the reports are showing that even the biogas sector can have a 12% greenhouse gas reduction if we use all the feedstocks which are available. And we have a lot of feedstocks available. We can use sewage sludge, industrial waste, we can use municipal solid waste. And if you look at what we have in Europe already, then we have 18,000 digesters of some larger scale already there, and more than 75,000 jobs related to that. The International Energy Agency, they even predicted that biogas will play a prominent role in the total mix. Reason being that we not only provide, say, a renewable energy, we provide much more. We can provide carbon sequestration on one hand. We can provide a solution for waste. We can provide cleaner cities because the transport can drive on very clean energy. So there are many extra things, like the benefits of reducing the chemical fertilizers we have in the world by using the digestate we produce. So the advantages are huge. And the International Energy Agency says also that biogas can be used for electricity, but also for biomethane, and it will be in future predominantly being used for biomethane. So yeah, I think it is time to have a look on what we can do within this seminar, and focusing really on the feedstocks, because the feedstocks are very important to see what it can produce, how much it can produce, what the characteristics are, and where and how much we can produce, and how that all looks like. So the seminar of today will really focus on that. And I would like to give an overview, and I'm not sure if we are sharing the screen of the slides. In the meantime, I'm just talking, but there are some slides on the background which can be shared. But we'll have today some very interesting speakers. So we have some speakers from DiBiCoo, basically enlightening us on what sustainable feedstocks are, which can be used, and what the characteristics are. Also, we have a speaker from the CHIP, which is the Italian Biogas Organization, focusing on the feedstock of especially sequencial cropping. Then we have some examples and some opportunities from South Africa and Indonesia. And I'm very, very curious to what they will bring as well. So before we go ahead, I would like to point out maybe a few housekeeping rules. The webinar of the seminar as we organize it is having quite some opportunity for questions. So after the first two speakers, after we speak the first and the second, we will have opportunity for questions. And questions you can place within the question box. You cannot raise your hand because we cannot, with such a big audience, we cannot have this very broad interaction. But when the questions are coming in, I will have a look at it and I will address them as far as I can. If there are not too many, but I hope there will be many, I will address them to the speakers. So please make use of that. Then the time will be strictly, how do you say, being looked at. So for the speakers, that will mean that you will have a time slot and we'll keep to that. But it will also mean for the questions that I will allow for the time which is there for the questions to be answered. Now you will see also that a data collection, we had some data from you that it will be only being used for the purposes of this seminar and will be not used for other purposes. And last but not least, and probably many of you will use that, the seminar will be recorded and is available on the website of DiBiCoo. So, without further ado, I would like to introduce the next speaker. And the next speaker has a wealth of experience within the biogas sector. And also he is very versatile, I would say. A scientist, an agricultural biologist by nature, but also I would say a consultant and flying all over the world, giving training and seminars to people who want to learn more about biogas. And he is also active, and he was one of the founding members of the German Biogas Association. With more than 30 years of experience, he will tell us a bit about feedstock and its characteristics. And I've seen some of his presentation slides, and I would think that this will give you a real great insight on what feedstocks will mean and what you need to take care of when starting a biogas facility. So let me further introduce you, without further ado, Michael Kotner of DiBiCoo. The floor is yours, Michael.
Thank you very much, Harman, for this nice introduction. Yeah, very welcome to you all from my side here in southern Germany, from IBBK. We are doing a lot of trainings and consultings, but at the moment, due to this situation, we're doing a lot of this online. So we sort of made a small studio here in our office to be connected with the world.
That's excellent. Michael, can I just interrupt? I'm not sure if you're sharing your slides already, but if you do, we cannot see them.
Okay, I'm doing that
there they
now.
Are. Yes, thank you.
Working?
Well
okay.
done.
Yeah, I will do it full screen now. Just now. I hope it works.
Because we can see it. Thank you.
Okay. Yes. So and yes, and we're doing trainings, and this week we last week we just had on an online training, our international online training, and today my theme is at DiBiCoo the feedstocks, an introduction to feedstocks, and I will talk about feedstock quality and quantity, different gas yields from substrates, dealing with different difficult to digest substrates and needs for testing. So what kind of feedstocks do we have, or what kind of feedstocks are used presently? And I'm there like representing the case of Germany, where we have over 9,000 biogas plants and 2/3 of the biogas plants in Europe. We're using a lot of manure, about 41%, and we're using some residues from industry, some municipal biowaste, but half of the substrates of the biogas plants are energy crops. And these energy crops consist of corn silage, cereal grain, grass, sugar beet, fodder beets, and some landscape material and other material. So highly energetic energy crops mostly, and but also manure. But we've got other, of course, we've got other feedstock as well, and especially when you start a industry, you don't automatically go onto energy crops, and you might be in a country where this is not possible. For instance, China, energy crops are forbidden by law. So also in other countries doesn't make sense. So what do we have otherwise? We have manure, we have harvest remains, we have organic fraction, municipal solid waste itself, sewage sludge, grass, and food remains. These are mostly from communities, and then from industry, the food and beverage processing, the dairy and the starch industry, the cosmetic industry, biochemical industry, pulp and paper, slaughterhouse as well. So this is really the three pillars where our substrates will come from. And yeah, if you plant a biogas plant, it's really in the center of it all. It really has an effect on reactor design and operation, on your bacteria even, and yeah, and then the quality. What are the quality of the products coming out? Is it how is the gas yield? How is the gas quality? How is the quality of the effluent, and so on? Very important economic considerations are made when you look at the feedstocks, and if you pay for them, if you yeah, get money for it, or if it's for free, if you have to transport them for a long time, that is really very important to look at. And some yeah, some requests we have they say, well, we have 100 cows and we want to make 42 megawatt. Is that possible? Kind of thing. Or we have 5,000 cows, but they're all roaming free range. Can we still make biogas? Is it available? So really you have to look at that, at the transportability, at the technical availability of the substrates. And a first feedstock assessment is really necessary. What's the amount, what's the solids, what's the volatile solids, and the gate fees. And so how much, and is it available all year round, or do you have to substitute it with something else the rest of the year? That's really, really important to look at. You also have to look at the quality of the feedstock. You have a lot of constituents in your feedstock, and you have protein, you have fat, you have extracts, fibers, and so on. And are they all available for your digestion, or do you have a lot of ash, a lot of protein which is not digestible, a lot of lignin, and then it looks different? So that needs to be analyzed. And also the consumption of the bacteria, the residue gas, and then you come to the potentially fermentable organic matter. And there's quite a list what you have to do when you analyze a substrate which is not known, and even you might have literature data. I wouldn't calculate with them. I would calculate really with your substrates you have available, and you must make an assessment. Unfortunately, and I see it so often still happening today in countries where biogas is starting and they're really on the go and want to get a project going, they forget all about this. They do not test, they do not see where the substrate comes from, if it's available all year round and stuff like that. Just a very big biogas plant has been built in South Africa where this has not been obeyed and the plant's not running. So we want to really avoid that. Just spend these few hundred, a few thousand euros in front of project planning and construction before you spend millions to do that, please, man. That means that you can send some samples to us. We put it in our lab, and this is how it looks like. Often in the countries, there are no possibilities to test or to have a unified test. And also the tests are often much more expensive than here, because here we've got good competition. And if you plan a biogas plant, don't say I want a 3 megawatt plant, but you don't know what the substrates are. You just look at the substrates first, you look at the logistics, and then this determines the size of plant, not the other way around. These projects, I've seen it so often, have failed and will fail in the future. Storage characteristics. You also have to think about storage or pre-storage of your substrates when they come to your place. Don't think that you can put it straight in the biogas plant and that always works like that. So you need shunting area, you need even like storage area for silage here in the case of energy crops, and even with a case of organics, you need a sort of a pre-storage, some pre-storage area where you can slowly then add it to your digester. Generally, organic waste cannot be stored long-term. That is clear, because you have a continuous delivery and you must be flexible. And also you have to think about liquid material. You need to provide extra tanks for pre-storage, and that also needs to be planned into a proper plan of a biogas plant. So let's look at different feedstock characteristics. That's food waste. So that's a processing waste from industry. It's separated from municipal solid waste stream. It's the organic fraction of the municipal solid waste stream, or in large part, the so-called post-consumer food waste. So that's how it looks like, a restaurant waste. And you think, well, what can there be in the restaurant waste? But there's a lot of plastic you can see here, or bones or seashells, or then expired fruit from supermarket. It's all packaged, so you have to unpack it. You have plastic, cardboard, glass. That's very nasty if you crush the glass and then it abrades your pumps. Or then household bio-waste. It has a lot of contraries in there, metal, sand, wood, and so on. So this needs to be all sorted and so separated, first of all, and then still sorted on site. Easier substrates are waste streams which are available in large quantities. And we will hear later about the colleague from Indonesia that pome is really a good substrate for biogas, because it has a high temperature, so it's already there. It has high oils and greases, suspended solids, and so it's really suitable for biogas production. Or paper and pulp and paper mill influent. So also not so much in Europe, but also in Indonesia, lots of these effluents are available, and they are really well digestible. Very important are livestock manures. They're well known and they are available in significant quantities, but are they available and are they transportable? And because you have to remember, manure has a relatively low biogas yield. So the longer you transport it, the more money it costs you. Here we have got, and this you never must forget, please also do an analysis of your manure. Don't rely on literature and say, well, in Germany they have a manure which gives you 30 cubic meters per ton, so I always count on that. That's true. It can be completely different in your country, and it can be thicker or it can be thinner. So the more water you've got in there, the less biogas you have, and that's shown here. So please also do an analysis of your manure and take different samples, take it seasonally, and so on. That's really worth it if you're planning a manure plant. Crop residues and silages are not only expensive, but they can also really equalize your bacteria. Here, and this is very important, they can equalize your bacteria, and even it may not be allowed for you to use maize silage. Sometimes maize silage is important to equalize bacteria and to provide a very good C/N ratio in the feedstock. here are different harvesting times, and you have to choose the best one for your purposes. And then you get, from the same harvest, you can get different qualities, and that means there are different qualities and harvesting times. So that's for the energy crops. They need to be chopped. The surface needs to be high because bacteria don't have any teeth. Best is 5 to 9 millimeters. And then they need to be ensiled. And then they need to be taken off slowly. And we've got a lot of problems with silage because you can do a lot wrong if you don't know what you're doing. You need to have the right harvesting time, you need to have the right storage time and conditions. If not, then you get molds, and that is very destructive for the process. And it needs to be compacted well, and it needs to be covered. Even manure often is conserved in a silage pit. Here you can see an example from Italy where this is done in a bag silage, where you avoid fires in your manure, because chicken manure can get terribly hot and it can cause fires with a dry straw. So therefore you put it in your silo, and then you keep it there stored to obtain good energy. Straw is also very important, and it's looked upon in many countries, but you need a thermal, chemical, or mechanical treatment. Otherwise, the digestion of straw is not possible, and you need to also add nutrients and add macro and micronutrients as well. Otherwise, straw is not available, is not digestible on its own. Best the straw is if it comes from the animals. So the animals have urinated, defecated, or trampled on it, or chewed on it, and then it's the best prepared for the biogas process. Fecal sludge, and this is a huge source of substrate. It's available in very big quantities in many developing countries where they don't have an existing waterborne storage system, where they work with tanks. And there we have a lot of fecal sludge which can be digested and is a source of great nutrients. Last but not least, we have to also look at the gas yields, and the gas yields need to be tested. And you can see here that manures, especially cow and pig manure, have relatively low gas yields, but they have already the right bacteria. So that's why they're often combined with other substrates which don't have the bacteria in them already, and therefore that gives an advantage to the digestion. And especially if you have highly energetic wastes, leftover bread, or grease separators, you want to have sort of a buffer, and cow manure and pig manure that have a good buffer capacity. So that's very important. So we call that co-fermentation. If you add something to the manure, and that's what many farmers have been doing. They say, well, my manure is good, but I want to have a little bit more power and I want to have a bit more output. So I put in other substrates which fit well together, and they also enhance each other with their different properties and capabilities. And then that's what you have to do. You have to measure your specific biogas yields, and you have to make these lists and consisting of dry matter, of organic dry matter, of biogas, and what's the yield and what is the methane yield and so on. So this is very, very important. You have to do that, and you have to test every every available substrate and see how it works and how it behaves. So that's really important. Thank you very much for your attention, and I'm ready for questions. So unfortunately, this was only a very small glimpse of what we're doing and what we're actually teaching. Thank you very much.
Michael, thank you. This was very informative, and I know this is only 15 minutes to present something which is way more difficult to think about. There have been a few questions coming in, but let me first address two questions. One is maybe fairly simple, is especially for emerging countries and developing countries, wouldn't it be better just to say, okay, we have digestible feedstock, just chunk them in a digester, see how much biogas it produces, and then improve during the time you are there? Wouldn't that be a very simple approach?
That's what we have been doing in the beginning in Germany. There weren't many tests done, but then the biogas plants were very cheap. They could be built by used parts. And nowadays, this is not possible anymore. And mostly big investors from India or from Indonesia, or wherever, they want to have their biogas plant operating very well from the beginning, from the first day. Actually, they can't even wait until the bacteria have developed. That's already too long for them. So I don't think this is a good strategy. Only if you have money and time to play around, then you can of course do it. Yeah.
All right. Then in relation to that, we got a question coming in from Eric Poby, if I pronounce that rightly. And he is saying, can banana stock being used for anaerobic digestion? Would you happen to know?
Oh yes, that is working very well. Banana peels or leftover bananas, they work very well. They have a high sugar content, a high carbohydrate content as well, and some fibers as well. So they can be used very well in biogas plants. Yeah, no problem.
Okay, even though, because I know from banana peel, for example, it takes 2 years to rot away in the nature. But for anaerobic digestion, that's not a problem.
Yes, you have to chop it up, and you, of course, you have to see it that it has actually, you have to actually, again, you have to do testing with the banana peels because they mostly are deep dived into chemicals, and that might be bactericide. That means that it kills the bacteria. So you have to check it first if it's possible to digest, and then you have to adapt your bacteria slowly, because the bacteria can adapt around these bactericides and also work as well.
All right, okay, well, that's interesting. You mentioned already in your presentation, you do a lot of testing. I see various questions coming in with regard to mango, pineapple, papaya feedstocks. Would you happen to have general data on that?
Yes, yes and no, but if we look at, for instance, mango and so on, there's a lot of pips in there. So mango pips are not digestible. It's more the peels again, and sort of the leftover flesh. The pips are I would not recommend using. I would actually phase them out completely, or burn them, or dry them and burn them. And we have got quite a big database on different substrates, and if we aren't sure, we test. Yeah.
All right. I'm seeing that is great answer. I'm seeing also some questions coming in on mango pulp and sulfur content, and if that can be digested, but also a question on paddy straw. Do you have any data, or can you say something about that? How easy it is to digest that?
Straw is a very good substrate. I know paddy straw is a very big hype in India. They try to do that, and there are all kinds of seminars and online seminars on there, and I can see that. Yes, it is working, but you have to pre-prepare it properly, or you have to use the right technology. For instance, dry digesters or irrigation digesters, things like that. So we actually we have a few projects in India where we do help them and get on the right track.
All right, but it's not straightforward.
It's not straightforward. It's not plug and play. You have to really look at your substrates. And again, I say, don't underestimate the substrates and make a good decision then, and spend a little bit of money. If you're serious about your project and you think it's going to work, spend a bit of money and first look at your substrates properly. It saves you millions afterwards, really. I've seen it so.
Okay, but yeah. That's a very good and wise advice by the sounds of it. Then two more questions to ask, and then we go on for the next speaker. One is a question with regard to the fecal sludge, which had such a low percentage. Could you elaborate on that, or can you elaborate on that?
Fecal sludge comes from septic tanks, and septic tanks are near houses. So the fecal sludge has different origins. It comes from waterborne systems which are local in a house, so that's rather thin. Or then it comes from pit latrines, which is thicker material. And of course, for biogas, we would like to have the thicker material rather than the thinner one. But it all comes at once. So we have also had a project now in Ghana, a very big project of fecal sludge in Accra, where we designed a plant. It's quite a unique design, together with a biogas plant and further biological treatment steps, which do not need any additive. That's very important, because they all need to be imported, and also the technology needs to be fixed. So this is, but we have a limited amount of gas from the fecal sludge, because we never know how old it is. Again, the rule is, the fresher the material, the better the gas yield. That counts for manure, and also counts for human manure. It's the same.
Yeah, that's what I noted also in your presentation. I want to highlight as well, of course, fresh manure will have the best the biogas production. So if you have to transport it, or you have to wait for a long time before you can get it to your biogas facility, your biogas production will go down. Then the last question was with regard to water treatment. If wastewater has chlorine in it, and I'm just trying to see the exact question here, chlorine, soap, and sulfur. What do you need to do to get this working?
Well, chlorine is really a problem. It's generally a problem. You get always you get a gas depression, and so you should really avoid it. And if you have these kind of systems, I mean, small amounts don't matter, but if it's really infested and it's really wastewater streams with chlorine water, there you have no chance of properly digesting it. You have to do other chemical treatment and chemical wastewater treatment as well. Biology doesn't work very well.
Yeah, exactly. Okay, so then you need to flocculate the chlorines probably out of the wastewater first before you need to. So that it makes it more difficult.
It's a really big chemical treatment, and it's really expensive.
All right. Okay. I see really many questions coming in, and I'm really pleased about that. But it means also that I can't address them all, Michael. Although I know you you have quite a lot to say.
They've got our contacts, so they can ask these questions. And
yes, they
always
certainly can.
Part in one of our trainings where you have an hour-long question and answer session, which we have actually this week. I'm doing still also in parallel with our training. So welcome to join our trainings, and the next one will be coming up soon.
That's a very good suggestion. Many thanks, Michael. Let's move on to the next speaker. And the next speaker is coming from the CHIP, the Italian Biogas Association. And why did we invite them? Or him, Guido Bezzi. He is an agronomist by nature, and PhD in agriculture, and he's leading the agronomy area of the CIB, and it's not in this bio, but he is also a director of the Biogas Information magazine in Italy. Why do we focus on what the CHIP has to say? And this is also all to do with the Biogas Done Right concept. Actually, the Italian Biogas Association has done some great jobs on to see how we can actually make sure that we integrate many advantages of the biogas plants all together. So here we are, Guido Bezzi. He's going to talk a bit more on about agroecology and what is the relation of agroecology together with carbon sequestration and sequential cropping. All difficult words, but he is going to explain that. He will explain that within the Biogas Done Right model, and he will, and I already said it in the very beginning, he will say something about soil fertilization and what we can do with our digestate. Guido, the floor is yours. I'm very curious.
Thank you for your presentation, and good morning, good afternoon to everyone. It's a pleasure to be here to present our Biogasdoneright model concept. So some few words on Italian Biogas Association. It's the association of biogas producer in agriculture. So we use in our plant, we use mainly biomass, agricultural biomass, manure, and byproducts from agriculture, and not waste. And in Italy, we start to manage biogas in our farm, and we start to study this concept, this model, with a bottom-up approach, because our farm associated start to manage the biogas and start to have some facilities that improving their agricultural part with biogas, and we start to study and develop this model from our farm. And the idea is to mitigate the impact on the environment of the agriculture, and so the agriculture can be a problem for this, but for us the question is if the agriculture can be also solution, because in future we need to produce more, but with same land, and use very well our soil to produce. We cannot produce in new soils with deforestation or something like this. And in agriculture we have emission. The most of emission is from livestock and from rice, from fertilizers, from rice production. And we can with biogas, if biogas it's well integrated in our farms, we can manage this, because we are really linked to the agricultural production, of course, and we can use two of system, two of good system, natural good system to capture and organicate CO2, atmospheric CO2, and sequester CO2 in soil. And we need to sequester CO2 in soil via organic matter because we need to improve the fertility of our soil. Those are the basis of Biogasdoneright project, and those are the basis of the potential of this model, because we work with the soil. Our soil have to be more productive, and our soil is a good carbon sink. And also, when we have an agroecology approach with Biogasdoneright, we have a biogas plant well integrated in our farm. We can use also crop residues. We can use also well digestate as a fertilizer. We can substitute fertilizer with digestate, and we create a positive carbon budget in our farm. It means we can sequestrate the carbon in our soil, and we can improve our fertility. So this is an overview of the scheme of the biogas plant or Biogasdoneright and agroecology approach. The biogas plant is integrated in our farm. We can use manure. We can use biomass from crops or byproducts. But we use digestate that can return into the soil as a fertilizer. And another topic is the double crop cultivation. So we start to cultivate a second crop in the same field. It means a crop for food. It means a crop for feed or energy, and in this way we can improve the soil use, and also we can improve our production without lost production of food or feed. And so the factor that can start this system starts from the digester, from the biogas, because the biogas create a market for the second crop cultivation for the energy crops, and farm can improve their agronomic approach. Their agronomic approach is more sequential cropping, improve the rotation, improve the photosynthesis and the use soil efficiency, so improve the natural system of the carbon sequestration and carbon capture and sequestration, less fertilizer and more nutrient recycling via digestate, and more organic matter and soil conservation with an agronomic technique conservative. So our farm started to a conventional agriculture that in Italy is mainly, for example, for maize, cultivate 6 months per year our soil, have a good production, but with irrigation necessary, herbicide necessary, and hard soil tillage, so for example plowing, and with a stable or decrease soil organic matter in our soil. And we start from conventional agriculture, and we apply Biogasdoneright agriculture. It means we try to cover the soil 12 months per year. We have more biomass produced, so more photosynthesis in our soil, and more carbon organicated and more carbon sequestered in our soils. Irrigation is necessary. Herbicides are reduced because we have 2 crops in continuous, and we can reduce also herbicides. Soil tillage have to be reduced because we have two time when we harvest and sow the next crop. We have two time really hard work, and we have to reduce tillage because we have to do in short time. And but also with the reduced soil tillage, we have also an increase of organic matter in our soils. So it means from starts to classical agriculture NPK. I defined this agriculture NPK. It means agriculture with chemical fertilizer. In agriculture, CNPK, because also carbon is important, because we have fertilizer rich on organic carbon, and this is the way that our farmer have to improve in their technique. So digestate it's used really well as a fertilizer, as a good value for our farmer, because they can substitute fertilizers, and we go to the precision farming, or the more accuracy in the use of digestate when we cultivate. We can apply this. We are applying this now in our fields. For example, in this way, in this field we have harvested the winter cereal, and in the next day we can manage the soil with a strip tillage. We can fertilize with digestate, and we can put the seed of the maize, of the second crop of maize. And this is real. It's some machine that we have in our farm. And this is sequential cropping. This is the example. When you work in this way, you have really soil covered for 12 months, and also herbicide are not needed, or more or less not needed. How it's possible to improve the double cropping, sequential cropping, double cropping cultivation in farms? It's possible with a systemic approach. It's possible to apply sequential cropping really in all over the farm, or more or less all over the farm. It depends of the management of the farm, of the possibility of the farm. It's not the approach, the Biogasdoneright approach. It's really an approach created on the farm and created on the characteristic of the farm. It's possible also sequential cropping. It's not possible to apply sequential cropping, but it's a really adaptive approach. The idea is to improve the biodiversity, to improve the conservative agronomic technique. This is the idea. This is an example, a real example in our farm that can cover his field really well during all the year.
Guido, I have to ask you just to hurry up a little bit, so there is some room for questions.
Yes. So this is the organic matter in soil. In medium time, we continue to study this, but we have a good results in increase of organic matter in soil with the use of digestate and with the double crop cultivation and digestate. We are studying also indicators of global bioenergy partnership. Those are the result of indicator of environmental indicators. And the interesting is we can have effective positive agriculture, positive effect in agriculture, because with biogas well integrated in our farm, we can valorize animal manure with less the chemical fertilizer use, and we improve the nutrient recycling. We adopt conservative agriculture. So if you see on the right, with the Biogasdoneright approach, we can reach also carbon negative farm when we feed our digester with manure and crops or byproducts and manure, or less carbon negative farm. So it's possible to become agriculture from a problem to an opportunity for the climate change. So we have studied and estimate also the scalability in other countries of our approach, mainly Argentina, USA, UK, France, and other. This publication is it's impressed, and we reach interesting results of the potential of approach Biogasdoneright in other countries. It means Biogasdoneright, it's possible it's scalable. It's possible to apply this approach all over the world. And yes, about the environmental effect, with Biogasdoneright and biomethane, we have a win-win solution when the biogas is well integrated in our farm, because we can produce a biofuel, so lower emission from agricultural biocarburant. We can produce bioenergy, and we can also make carbon sequestration in soil via organic matter. And so that's all. Many thanks.
Yeah, many thanks, Guido. That is very nice and a very good presentation. I'll try to, in the meantime, also share my screen in order, and I'm not sure which screen you see now, so that is an issue. Yes, and which one? Because I have two.
The desktop.
Right, okay, so you see the slide with the time for questions?
No, now I see the desktop, your desktop, and I think.
Okay, so I'll do it in a different way. I'll go back to what we've done before. We have a few questions coming in. One of them, which is actually curious for myself, is that as you know that in Europe there's a lot of questions with regard to the sequential cropping. There's a lot of interest as well, and at the same time there is another question coming up, and that is all to do with biodiversity. So in Europe, they would like to see that the farmers are promoting biodiversity. So could you actually see if sequential cropping and biodiversity is going hand in hand?
Yes. So, but sequential cropping, it's some kind of biodiversity. So you have two crops in the same in the same field in the same year, and the approach of our farmers, to be honest, is not only sequential cropping for one crop for biogas, one crop for feed or food, but they can decide where the production, the harvest, it's better to for them in this way. And for us, it's not a problem. It's not a good a big problem for the biodiversity, because normally in our agriculture we improve the rotation, so we improve the biodiversity. We have also new crops that we cannot cultivate in our way.
All right. Okay. So that does solve maybe a part of the biodiversity problem, or we can participate. And I can imagine that you maybe also be able to do not a monocrop, but do several crops through each other if that is really destined for only anaerobic digestion.
Yes, yes. We start with biogas. We started with mainly with the maize, the silage maize cultivation. At the beginning was silage maize cultivation, but now silage maize cultivation it's more. We have substituted a lot of silage maize with I don't know, winter crop silage or byproducts, because in our experience we don't have a lot of soil to cultivate, and we have a lot of typical and high quality products. So we want to continue to produce high quality products, and we have to apply this approach in order to continue to produce our products, because are valuable products also them.
Okay, that's helpful. And what you see is, and I related in the beginning of this seminar, is that we have, if you calculate it worldwide, we can decrease with the feedstocks we have already 12% of our greenhouse gases worldwide, which is a huge impact. Although if you look at those studies, they don't even take into account sequential cropping. Okay. So on top of this 12%, actually, we can imagine that there is more to gain. And apart from that, and we didn't even touch upon that, is that you see that if you do sequential cropping, you also tackle one of the nitrogen problems, nitrogen emissions, which are there when the land is arable, instead of so covered with a second crop. So there is a lot of potential. Thanks for interesting presentation. I know there is a lot of work being done within the CIB and by you as well on this theme. And I think this needs to be distributed further without, not only in Europe, but also outside. As I think we can increase our biogas production as well as solve a few problems at the same time. So thank you, Guido.
Thank you.
I would like to go to the next speaker, and I would like to welcome Yassine Salih. He is a bioenergy specialist and analyst in South Africa, connected. He is connected to Green Cape, sorry about that. And he has also experience within the biogas sector. As a member also of the South African Biogas Association, he is there active, and he can also spread the word about the opportunities there are, and maybe also the limitations or the difficulties on how to develop biogas in South Africa. I know that also in South Africa there is a huge opportunity to go for biogas. So I'm curious, Yassine, what your presentation will be. Thank you.
Thank you very much, Harman, for the introduction. Just want to check, can you see my screen?
Yes, we can.
Okay, awesome, fantastic.
Am I just, hang on, not yet. I see a different screen.
Which screen are you?
Yes, now I see it. Hang on. Oh, now it's gone again. This is our general deck slide. This is your presentation. Yes, we have it.
Yeah.
Okay.
Awesome. Awesome. Thanks, Harman. Yeah. So thanks very much for the introduction. And I thought for this presentation, I'll just share with everyone basically what the feedstock potential is like in South Africa. Firstly, what Green Cape does in terms of an organization, how we've sort of identified the feedstock potential within South Africa, the opportunities that the feedstock provides, as well as some of the barriers in terms of accessing that feedstock, and then some of the learnings that we have from existing biogas projects with regards to feedstock, and a few conclusions based on that learnings. In terms of Green Cape, the organization that I'm a bioenergy analyst for, it is a non-profit organization established in 2010. And the focus of Green Cape is sort of to grow the green economy within South Africa and beyond. We focus on a number of sectors within the green economy. And our primary focus is to sort of assess the market intelligence for economic investment and job creation. These sectors within the green economy include sort of energy or the energy efficiency, water efficiency, sustainable agriculture, waste economy or the circular economy as well. And clearly that focusing on biogas or bioenergy is an overlap with all of these sectors. Through the work that we've done, done a lot of sort of investigation work in terms of trying to assess what the market potential for biogas is. The biogas market is often sized on two fronts. It's either sized on its energy potential or the feedstock potential. In the case of South Africa, it's mainly the feedstock is mainly come from the waste sector. And as you can see here, in 2017, according to the Department of Environmental Affairs State of the Waste Report, South Africa generated about 108 million tons of solid waste, of which about 19,000 tons was organic waste. And by organic waste, we mean these waste that are generated from biological residues. So that can be agriculture, municipal solid waste, food waste, etc. This is a large amount of waste that is basically going to landfill, and it basically presents South Africa with a huge opportunity or potential to sort of generate biogas or to be used in other biological process or value add processes to the organic waste. Further speaking to that organic waste, a study was conducted by Ecometrics Africa in 2016, and it was quite a nice study that concluded the biogas production potential for these sort of agricultural waste or organic waste. This was only an estimate based on theory, but as you can see, there is a few sectors that were highlighted to have significant potential. A large portion it is in the municipal solid waste sector, and that usually includes your sewage sludge as well. Then the other two big sectors are your sugar production as well as your agricultural residues or agricultural sector. And then another two sectors that have a relatively decent potential is the municipal wastewater and paper and pulp. The three sectors that are food processing and brewery and abattoir, these also hold potential, and I'll explain exactly why they considered it as attractive sectors to biogas as a feedstock, and that's based on the sort of opportunities within South Africa, or the current context that is driving that as an attractive sector. In terms of opportunities for feedstock, the opportunity for feedstock lies within the following sectors, and these are sort of the biggest or the sectors that hold the most potential for feedstock for biogas. The first one is your dairies and feedlots. The second is your food processing or your primary and secondary agri-processing sector. The third one is your piggeries, your poultry farms, abattoirs, winery, breweries, and lastly, your hospitalities or shopping mall sectors, so to speak. These opportunities were sort of identified based on existing projects and how successful these projects have been implemented and the challenges that these projects have faced. Another driver for opportunity for waste as a feedstock for biogas, particularly in South Africa, is that in 2018, abattoir waste was banned from landfills. So there was a sort of outcry or demand for a solution for abattoir waste. Biogas is often seen as one of the potential solutions for this. And the reason being is that biogas can treat or add value to large volumes at a time compared to some of the other available technologies. Also, it was also described that the liquid waste ban to landfill would come into place. This basically means that waste streams with a certain moisture content will no longer be accepted at landfills. This also provides another opportunity for biogas. So, and lastly, the organic waste ban, which was sort of predicted was being staggered in terms of waste as a ban to landfill by 50% within 5 years and 100% in 10 years. So we're looking at 2023, we expect 50% of organic waste to be diverted from landfill, and 2028, 100% of the organic waste to be diverted by landfill. This is being led by the Western Cape as a province. Other provinces have not sort of had it presented that they will be having these bans. However, on a national scale, organic waste and the value add to organic waste and the diversion from landfill is a priority for the government. So this essentially means that your waste or your organic waste is a very big opportunity to drive the implementation of biogas plants, because it is such a attractive feedstock for biogas plants. However, that being said, organic waste comes with its own issues as a feedstock for biogas plants. The very first one is the quality of the feedstock and the level of contamination. Often, if you're dealing with municipal solid waste or food waste or waste that comes from the hospitality sector, if you would like to use that as a feedstock for biogas plants, it obviously has a lot of packaging waste or contaminants in it. Similarly, within the agricultural sector, because those residues are not sort of set up to be fed directly into a biogas plant, it is often contaminated by sand or other sort of agricultural contaminants. So if you look at a dairy farm or feedlot, if you would like to use manure for your biogas plant, it would obviously, the farmer doesn't have a collection method, or as Michael mentioned, if they are cows that are roaming free, often that manure gets collected with a lot of sand. Another barrier within South Africa particularly is the value of feedstock, and that comes in three forms. The first one is that the owner or the generator of that feedstock doesn't have a good understanding of what the value of the feedstock that they have, and often they just dispose of it, or they get sort of influenced into charging quite a lot for that feedstock, which speaks to sort of the market value currently for feedstock. In most cases, biogas plants would have to sort of take on that feedstock as a gate fee for the projects, and they have to come in at a value less than what the landfill gate fee is. Most places in the country that's extremely low. However, there are provinces in the country that have a higher landfill gate fees, which makes it more attractive for farmers to sort of dispose of or to send this feedstock to a biogas plant or biogas plant owner, so to speak. So the market value is very sort of inconsistent, and it's often based on a negotiation case by case sort of scenario. Other issues around the value of feedstock is competing technologies, and the reason why this is an issue is that you would often get other technologies or other solutions for that feedstock, being able to pay for that feedstock or to compete with that biogas plant and offer more value to the generator. And that's how a biogas plant may lose out in terms of getting access to that feedstock. Michael spoke about the location of the feedstock. I'll show you on the next slide in terms of how that impacts South Africa. South Africa is a very unique country in terms of its setup, and there's certain regions where it's more favorable and the location of the feedstock is easier to access, and there's other locations where you have to transport quite large distances in order to get it to a biogas plant when it is established. Then lastly, with regards to one of the issues around feedstock that can be considered a barrier for biogas at the moment is the legislation. Biogas plants, because it can handle and add value to feedstocks in large volumes, it often has to go through a full environmental impact assessment according to the legislation of South Africa. This can easily take up to 18 to 36 months. The ideal phase that we can get minimum time is about 18 months, but it can drag on for quite a long time. And that can create a barrier because the feedstock is still considered a waste, and you'd have to sort of ensure that you complete the environmental impact assessment for the site before you can add value to that feedstock or that waste. I mentioned the distance in terms of location of the feedstock. Here's sort of a nice. Yeah.
I have to ask you to speed up.
Okay, no problem. Almost done. Thanks so much, Holman. So in terms of the proximity, the Bioenergy Atlas sort of gives a nice map in terms of what is the ideal location within the country. As you can see, it's more favorable within the Cape Town region and Johannesburg, Pretoria region in terms of accessibility feedstock based on existing infrastructure. Then lastly, in terms of the existing projects where all the opportunities and barriers were highlighted, in Green Cape's investigations, we sort of highlight, investigated and found 26 projects that have been implemented in the country, and that's in the commercial industrial sector. One has been sort of completely decommissioned. Another one is completely not operational at the moment. And then there's 24 of those projects that have sort of been on and off operational. A lot of them are not operational, but they still claim to be operational in some capacity. In terms of the feedstock breakdown, 4 of those projects came from abattoirs, 3 of them in the bovine-related category, 2 at piggeries, 3 at poultry farms, 6 at food processing sites, 2 at shopping malls, 3 had sort of land rehabilitation where there was some sort of energy crop involved, 2 at wastewater treatment works, and the last one is the sort of integrated waste management facility that Michael mentioned in Cape Town. The learnings from this project and the impacts of feedstocks is that it's quite key to South Africa does have a high potential for biogas due to feedstock, but there's no project if the feedstock is not accessible and is not a good quality. What these projects have learned in terms of feedstock is that there has to be a collaborative effort for successful implementation to add value to the feedstock. So if a farmer can only make the feedstock or the, say for example, the piggeries slurry available at a certain time, the biogas developer has to make sure that you can basically feed that feedstock into his plant as soon as possible. If there is a discrepancy and there's no collaboration, that feedstock might be in storage for quite a long time, and as Michael mentioned, can lose a lot of its biomethane potential, and the output of the biogas can be reduced. In terms of other mistakes that we can learn from within South Africa, the good example is the integrated waste management facility that Michael mentioned as well. That project, because municipal solid waste is changing quite constantly within the sort of Cape Town or South African region, and that's due to population growth. It's quite hard to sort of assess what the quality of that organic waste food residue would be unless you have sufficient pre-treatment stages up ahead or source separation at source. to improve the quality of the feedstock. So it's quite important to make sure that if you are implementing the project within South Africa, that the feedstock you are targeting firstly has sufficient quantity in terms of volume, and that it is of a high quality and it requires minimum amount of pre-treatment for that biogas plant. I think that is it from my side. I'd just like to say thank you.
Yes, well, thank you, Yassine. That was very clear. And once again, we are being highlighted that quality is very important. We cannot take now questions because I would like to go straight ahead to the next speaker, but bear one thing in mind. I'm just calculating quickly the area size of South Africa compared to Belgium. You are more than 40 times bigger, but you will produce in the potential of feedstock only twice as much. So I think there is a lot more potential to gain in South Africa. But we can talk about that maybe after this seminar. But let me introduce the next speaker. And I'm very pleased to introduce Elizabeth Rianawati from Indonesia. It's evening at your side, I believe.
Yes.
So
yes.
It's very good to have you here. Thank you for your attendance. To the listeners, we have here actually a real thinker, because this is the CEO of the Director of Resilience Development Initiative, a global think tank on several issues. One of the issues you're really busy with is, of course, the renewable energy, and especially in rural areas. And you're also focusing on biogas. So a jack of all trade, but focusing in Indonesia without giving it too much away, but of course on pomi, on tapioca, but also soya bean and tofu. So I'm very curious. I've been in these countries developing biogas projects myself as well. So
Wow.
I'm really curious what you were saying.
Okay. Thank you, Harman. Maybe later you can help me with the question, because I believe you are more aware of what we have here in Indonesia. So yes, I will be short in my presentation. So let me see. I hope you already see my screen and my presentation. Is
yes,
it?
we can.
Okay, so yes, before Hoyamidas, buenos tardes, Indamin Walachu, Memo Aha. So we are combined here in Digital Biogas Corporation, while we are target in our 3 years project to expand the anaerobic digestion or biogas plant more in the countries that have a very good biogas potential. So welcome to the participant from Argentina, Indonesia, Ethiopia, Ghana, and South Africa. Okay, so in Indonesia, as Michael and Harman has mentioned before, we have a very high potential of biogas from POME, from palm oil mill effluent. It's one of the biggest, but actually we also have another type of feedstock like municipal solid waste, corn, sugarcane. So actually we also have a lot of organic from agriculture, but right now I think is being in a competition with bioethanol production. So for the biogas, target is mainly focusing from the waste sector of the factory. And this is just an example how the government tried to push the implementation of biogas plant in Indonesia, especially in POME sector. So this is just an example of the biogas plant that is being developed within 2 years in 2015 and 16. So we make this 4 big biogas plant with a capacity of 1 megawatt. And then the type of the anaerobic digestion being used or the biogas plant is mostly covered lagoon. But although the government also pushed for CSTR, complete stir tank reactor, So because why the covered lagoon is mostly being used, so out of the 800 of mills available in Indonesia, the registered one is only around 36 methane capture. So the market potential is big in Indonesia actually for the biogas plant from Pome. And this is the blue box here is a comparison of the biogas produced specifically from Pome, and also in comparison with the LPG usage that we use in Indonesia. So actually, if it's done correctly, it can be a substitute for the LPG in the future. And well, okay. And then this one is also a type of another feedstock that is being promoted in Indonesia, is from organic fraction of municipal solid waste. So we have among a lot of cities in Indonesia, one big city, Bandung, is being piloted to treat the organic fraction of municipal solid waste. So we can see here a lot of scale of biogas to treat the organic fraction from the household scale, the communal scale, and also the bigger one up to 200 ton per day. Actually, initially we aim much bigger, like centralized city, but up until now it's still in the planning. And then the next example is the manure-based digester. So previously we have already installed like around 14,000 of micro scale manure-based biogas plant. So not plant, biogas digester. So but this time we try to aim a little bigger for this dairy company in West Java, where the capacity is 250 ton per day, and the biogas is used for the boiler, and the technology is actually from Italy. And the next example, maybe this can answer also some of the question that being asked from the participant, is there is a piloting undergone right now to produce the biogas from pineapple processing and combined with liquid manure and also starch production. And apart from that, separately, because in Indonesia we have so many soybean tofu factories, usually there is 3 types, volumetric base of soybean tofu factory, around 40 to 90 meter cube of capacity. So the government just recently make a pilot for this 3 volumetric base factory, and to see whether it's profitable or not. And this are some of the published report by the Ministry of Finance. So they try to estimate the profit obtained from the this one is from the organic fraction of municipal solid waste. So we can see here that for 100 ton per day capacity, it will give quite some of profit here. And also for the palm oil mill biogas plant will give profit if it's used internally for CHP instead of selling it for the electricity grid, because usually the palm oil mill is located far from the main grid. And this is the projection of profit from soybean biogas plant. So it's not much the profit, annual profit, but the government really tried to show that it can be done, and it's good for the environment. So yeah, they really try to push more implementation of the biogas plant in soybean factory. And yeah, I conclude my presentation here, and I give back to you, Herman, the time and is yours.
Well,
Thank you.
thank you, Elizabeth. That is very interesting indeed, and a lot of good examples on what is possible in Indonesia. I think we have only a few more minutes left, so maybe it's a good idea to have also the other speakers online to ask a few general questions to the speakers. There have been a few coming in. But maybe starting with you, Elizabeth, I had a question from Mark Christoph Rudolph, and I'm trying now to get it back online. How does the development of municipal solid waste in Indonesia in terms of waste to energy, how does that go? Is there any improvement?
Wow, okay. That's actually a long story, Herman. I don't think we have time for the whole story, but actually, as you know, the main focus is actually on thermal technology, but it has been opposed by the community in all cities. That's why we are doing this piloting in Bandung city. Bandung is a hilly city, so it's basin, so it makes it more suitable for fermentation base, but still the government is pushing for the thermal base waste to energy technology, and now they are increasing the feed-in tariff. So yes, several cities are progressing well.
All right, okay, that is good to hear, and especially maybe in future also gas supply replacing, say, natural gas would be an idea to promote. I think if we look at the conference so far, we have had actually all connected stories, and one which of course springs out of it is the quality of your feedstock. Michael already showed that of course you can just junk in some of the feedstocks in a biogas digester, but you will never get it to work, or you'll get some bad results, resulting actually in losing money instead of gaining money. On the other hand, we have seen also from Yassine and Elizabeth that we see that it is best to look there where the feedstock is readily available, not to immediately look for different feedstocks, but go or either in agriculture like POMI, or you go to municipal or industrial waste. However, I do have a question actually for all of you, and maybe Guido, maybe that's something for you to answer first. Is we see in the world that fossil is being subsidized still heavily. Biogas, in respect to that, is then very expensive. How would you make sure that we can actually promote, on one hand, our industry so well that we can develop the feedstocks, and on the other hand, make sure that all the entrepreneurs who are busy in that also making some living out of that? Do you have any thoughts on that, Guido?
That's a good question. But I think a way for Europe and for biogas in agriculture, it's to push to the gain in environmental part and in the potential of the agriculture to combat the climate change. And I mean, we have a lot of potential if we work as I showed in carbon sequestration. So to give value to the carbon sequestration in our soil. In this way, we make a work for the community, and we subsidize also biogas, etc. So also in the other part, I showed also we can work to less the environmental impact of the transport, and with biogas we have a huge potential with the heavy transport and naval in the industry, etc. So we have to work in this way, in this market for me.
Okay, thank you. And I do think indeed the transport is one of the issues where we can play a big role as well. I do have to look as well. I've seen so many questions around, so we cannot answer them all because our time is already up. So I would like to actually ask you, all of you, and I will start with Elizabeth. If you want to give advice to anybody who wants to develop a biogas plant, what would your advice be? And just put it in 1 or 2 sentences, if you can.
Oh, okay. My advice will be like, it's a very difficult question. Okay, make sure, for Indonesia, okay, for Indonesia project is that make sure that you involve the government, because right now the government has a big interest in having more biogas plants, so they will provide more incentive for you. So that's mine.
Wow, well, that's a very good advice, I would say. Michael, any thoughts on that?
Well, next to the good government incentives, we also need your own involvement. So please stay informed. Please be informed. Look at other projects. If it's the right thing for you, do you have the right amount of substrate? So it's really, I would say, just be informed to do your project well.
Okay. Yeah, that came clear from your presentation as well, that it all starts, of course, with the feedstock. Yassine, how do you see this from the South African perspective?
From the South African perspective, I think what is key for someone looking to develop a biogas project is maybe considering making sure that it fits within a sort of circular economy model. So as Michael has mentioned and everyone else has mentioned, the feedstock is quite important. But that biogas project plant would thrive a lot more if there's a usage potentially on site for that biogas, if there's heating facility needed or electricity or energy required, if the digester can be used for agricultural purposes. So definitely consider that sort of circular economy model and try and use the products that are produced as much as possible on site. And that would reduce sort of the risk attached to developing the project.
All right, so a real integrated approach in the total. Oh, thank you. Guido, any last words on this question? And an advice question for our audience in 1 or 2 sentences?
So also for me, integrated approach, it's the base. Because if you don't integrate the plant in farm and in other production, cycle production, you cannot gain all the positive revenues from the biogas. And also, I agree with Michael for the biomasses. First, you have to know the biomasses that you have, and then you can develop your biogas plant well in positive way.
All right. Okay. Well, thank you all. I mean, as we are always with these kind of subjects, we could talk on for hours and we could inform each other, help each other. So I would like to say to the audience as well to reach out to DiBiCoo website. We have all the presentations online, so we will not send it to the email addresses, but you can take it from online. You can ask us, the presenters as well, to elaborate if you have any questions. I would like to thank you, speakers, for such a good and very high informative presentations. That is absolutely, that's key to the success of the biogas industry. So thank you for that. Wrapping up, I think we have learned a lot about feedstocks and how to tackle that, to look at quality, to look at the amount and what we have and what we can do before we actually start a biogas project. But we also saw there is a lot of opportunity. And as the International Energy Agency already showed, the eyes and ears are actually open of the local governments and also the national governments towards biogas projects. So let's take that up and see what we can do. Then I would like to also highlight that the seminar series will continue. This was the third in a series. The next one is coming up on the 17th of November, and you can put this already in your diary. And that is all about sustainable biogas production and how to use that. I would say stay tuned. Make sure that you reach out to us and to the speakers. Thank you for listening, and I would like to thank you also to the team who organized this to make this happen. I wish you all a very good remaining morning or afternoon or remaining evening. Goodbye.